Hello everyone. On this video we will be looking at the slope and tangent lines of a polar curve. Okay, so to do that, first we're going to kind of give a quick explanation as to how we're going to approach it. Okay, so to find the slope of a tangent line, for a polar curve, consider the differentiable function r is equal to f of theta. Okay, so now for your f of theta, you think about it this way. If you have your ordered pair xy, since y is equal to f of x, you can make that x f of x. Okay. Same thing with polar equation. If you have the ordered pair r theta, that can just become r equals f of theta, so you have f of theta, theta. Okay, so starting off, we're going to go back to our parametric equations. Okay, so using parametric equations, x is equal to r cosine of theta. Since r is equal to f of theta, you have x equals f of theta, cosine of theta. And y is equal to r sine of theta. You can rewrite that as y is equal to f of theta sine of theta. Okay. Now if you like, you can leave it as r cosine of theta, or that. Either way, it's perfectly okay. It's all a matter of your comfort level. Alright, so you remember your derivative for a polar equation. You have dy d theta over dx d theta. Remember, your theta is your parameter on this one. You just apply the product rule for derivatives. You have the first times derivative of dy d theta, first times derivative of the second. So f of theta, derivative of sine is cosine, so that changes there, plus the second times derivative of the first, so you have sine of theta f prime of theta over dx d theta. You have the first times derivative of the second, so you have f of theta. Derivative of cosine is negative sine, so we have sine of theta, and we'll just put the negative right out here, plus the second times derivative of the first, so you have cosine of theta and f prime of theta. Okay. Or if you wanted to, you could make it r cosine of theta plus sine of theta dr d theta, since f prime is just dr d theta, over negative r sine of theta plus cosine of theta dr d theta. Excuse me. So really, either one of these will be acceptable. Oops, sorry, didn't mean to cut that off there. Dx d theta Okay, so either one of those would be, they're really the same thing, so you can use either one of those formulas. Okay, which brings us to just our theorem. Okay, so if you're writing, feel free to press pause, but we're going to go ahead and move on. Okay, so if f is a differentiable function of theta, then the slope of the tangent line to the graph r equals f of theta at the point r theta is basically our formula from the previous page. dy dx, which is dy d theta over dx d theta is equal to f of theta cosine theta plus f prime of theta sine of theta all over negative f of theta sine of theta plus f prime of theta cosine of theta. Or, again, you can use r and dr d theta for f of theta and f prime of theta if you like. Not necessary. Like I said, again, it's all depending on your comfort level. And that's where dx d theta does not equal 0 at r theta. All right. Now, quick note. Move that up a little bit. That solutions to dy d theta equals 0 yields the horizontal tangents. When dx d theta does not equal 0. Okay. Similarly, solutions to dx d theta equals 0 yields the vertical tangents. But that's only when dy d theta does not equal 0. Okay. But if both equal 0, so if your dy d theta equals your dx d theta, and they both equal 0, then no conclusion can be drawn about the tangent lines. That's not saying there's no way to find it out, but you just can't do it using this particular method. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and start on our first example. Okay, please excuse the shadow here as the sun moves. So does the light flashing on my recorder. So hopefully you can ignore that. But for example, let's say if we wanted to find the slope of the tangent line. To the polar curve. Excuse me. R equals cosine of theta over 3 at the point theta equals pi. Alright. So, to do that, first thing we do is we look at our formula. Where dy dx is dy d theta over dx d theta, which is equal to, instead of f of theta, we'll just use r cosine of theta plus dr d theta sine of theta all over negative r sine of theta plus dr d theta cosine of theta. Okay, so all we did was use the r instead of f of theta and dr d theta instead of f prime of theta. Again, you may have some problems that instead of r equals, they may say f of theta equals. This way you're familiar with both. Okay, so to kind of clear that up just a smidgen, make sure there's no confusion. F prime of theta is our dr d theta. F of theta, that's our r. Okay, now that means our dr d theta, so derivative of r with respect to theta, so we just find the derivative of cosine of theta over 3, which is negative 1/3 sine of, oh, sorry about that, ran out of space, theta over 3. Okay, so now just go ahead and replace r with cosine of theta over 3 and our dr d theta, our value here. Okay, so that's going to move that over a little bit, equal cosine of theta over 3 times cosine of theta plus our dr d theta, negative 1/3 sine theta over 3 times sine of theta, all over negative r, so that's negative cosine theta over 3 times sine of theta, plus dr d theta, so we have negative 1/3 sine of theta over 3 times cosine of theta. Okay, now that you have that, when theta is equal to pi, screw that up, then that's just going to equal cosine of pi over 3 times cosine of pi plus negative 1/3 sine of pi over 3 times sine of pi, all over negative cosine of pi over 3 times sine of pi plus negative 1/3 sine pi over 3 times cosine of pi. Okay, so now we get each individual factor and we simplify it. Okay, so cosine of pi over 3, that's 1/2. Cosine of pi is -1. Plus, you have sine of pi is 0. Now, as soon as you have sine of pi is equal to 0, you really don't have to solve that one if you don't want to. But I'm going to go ahead and solve it. I'll move that over. So -1/3 times sine of pi over 3 is -square root of 3 over 6. So we have -square root of 3 over 6 times 0. That's our sine of pi. Over, again, you have sine of pi, which is 0, so you don't have to solve that one. I'm going to do it anyway. So negative cosine of pi over 3 is -1/2 times 0. Plus -1/3 times square root of 3 over 2. That's -square root of 3 over 6. Oh. So that's cosine of pi, again, is -1. Alright, so again, everything multiplied by 0, those terms disappear. So we have -1/2 over positive square root of 3 over 6, which simplifies to -3 over square root of 3, which is equal to, once that's simplified, -square root of 3. If you replace 3 with square root of 3 times square root of 3, that'll cancel out, leaving you there. Alright. Okay, so if you are still writing, feel free to press pause. But we're going to go ahead and go to our next example. Alright, so let's say, for example, we wanted to find the horizontal and vertical tangent lines for r equals sine of theta. And that's from 0 to pi. Alright, so first thing we're going to do is we're going to rewrite it in parametric form. Just to make things a little easier. Okay, so x equals r cosine of theta. Since r is equal to sine of theta, we'll make x equals sine of theta cosine theta. Okay, and y is equal to r sine of theta. We're just going to make that y is equal to, instead of r times sine of theta, be sine of theta times sine of theta. Or if you want, you can make it sine squared theta here. Sine, sine, sine squared. Okay, so we got a little square on those so we can keep those separate. Okay, so if you remember, find the horizontal and vertical tangents. Our dy d theta equals 0 yields horizontal tangent when dx d theta does not equal 0. And your vertical tangent, dx d theta equals 0, yields vertical tangents when dy d theta does not equal 0. Okay, so you want to remember those when you're looking for your horizontal and vertical tangents. Okay, so once we get started, we see that our dx d theta equals, we use the product rule, first times the root of the second plus second times the root of the first, we end up with cosine squared theta minus sine squared theta. Which, if you remember your trig identities, that's equal to cosine of 2 theta. Okay, so you want to find out when dx d theta, which is cosine of 2 theta, equals 0. Okay, when does that equal 0? Well, it equals 0 when theta is equal to pi over 4 and 3 pi over 4. Okay. Honestly, there are infinite many more spaces where that would equal 0, but we have a range we have to stick to between 0 and pi. Okay, so that's between our 0 and pi. Okay, so now looking at our dy d theta. Okay, so derivative of y with respect to theta, you can use sine squared or you can use the product rule here, but you end up with 2 sine theta cosine theta, which, using your trig identities, is equal to sine of 2 theta. Okay, so dy d theta, which is sine of 2 theta, equals 0 when theta is equal to 0 or pi over 2. Okay, so we have our theta values. Okay, but that doesn't tell us the vertical and horizontal tangents. Okay, how do we find that? Easy. We plug into the original r equals sine of theta. Alright, so unfortunately I'm running out of paper space here, so I have to continue that on the next page. So if you are still writing, feel free to press pause, but we're going to continue this on the next page. Alright, bring that back down here, and go ahead and continue. Okay, so remember, r is equal to sine of theta. So a quick flashback to the previous page. Here we go. So we have pi over 4, 3 pi over 4, and we have 0 and pi over 2. Okay, so sine of pi over 4, that's equal to square root of 2 over 2. And sine of 3 pi over 4 is square root of 2 over 2. Okay, now we're going to just use those two because remember, we're just looking for your dx d theta, and those are your dx d theta. Okay, so dx d theta equals 0, give us our vertical tangents. Okay, so our dx d theta equals 0 gives us our vertical tangents. Okay, now we still have 0 and pi over 2, so sine of 0, we know that's 0, and sine of pi over 2 is equal to 1. So these two will give us our dy d theta equals 0, or our horizontal tangents. Okay. Now all you have to do, put these in your r theta form. Okay. So remember that I'm just going to use one as an example, but this is your r, and this is your theta. Okay, so you have your r and your theta, your r and your theta, your r and your theta, your r and your theta. Okay, so for your vertical tangents, remember it has to be in the form of r theta. Okay. Okay. When r is square root of, well, r is square root of 2 over 2 when theta is pi over 4. Okay, so square root of 2 over 2 when theta is pi over 4. And r is square root of 2 over 2 when theta is 3 pi over 4. Okay, so I have square root of 2 over 2, 3 pi over 4. Alright, so now let's look at our horizontal tangents. Again, it has to be in that r theta form. Alright, so we know that when that r is equal to 0, when theta is equal to 0, so we have 0, 0. And we know that r is equal to 1 when theta is equal to pi over 2. So we have 1 pi over 2. Okay, so we have our horizontal and vertical tangents. Okay, so how would that look as far as a graph? I'm glad you asked that question. Okay, so r equals sine of theta will look pretty much like that. So your vertical tangents, I mean your horizontal, well, let's start off with vertical tangents, would be this point here, and about, let's say, this point here. Okay, so this point, that would be your square root of 2 over 2, 3 pi over 4. So remember, your radius goes from here, it goes all the way to 3 pi over 4. And this would be your square root of 2 over 2 pi over 4. Remember, your radius starting at 0 would go up to pi over 4. And same thing here, it would start at 0 and it would swing over to 3 pi over 4. Okay, so now your horizontal tangent, you have 0, 0, so you're looking at about there, so it would be your 0, 0. And your other horizontal tangent would be 1 pi over 2. Let's clean that up a little bit. 1 pi over 2. Okay, so that's how it would look in graph form. Alright, so hopefully this made sense, and I will see you on the next video.